Hello students, in the previous class we discussed about the introduction of compass surveying, right? We discussed the introduction for the compass surveying. Okay, so what is meant by compass surveying and what is its requirement and what is its objective, why compass survey is needed. Then we discussed about what is mean by bearing, right, and what is mean by meridian, right? What is meridian, what is bearing, and what are the different types in bearing as well as in meridians. We have in meridian true meridian, magnetic meridian, arbitrary meridian. In the case of bearings, true bearing, magnetic bearing, arbitrary bearing. Okay. Now we will see in today's class, right, representation of bearing, right? What is mean by bearing, right? If you are taking any angle with the fixed reference direction, it is north direction of a survey line. If it is a survey line, right? If you are mentioning any angle with respect to some fixed direction, that is north direction, that is called as the bearing. Okay. So now to represent this bearing, we have two systems. Okay. This is the very fundamental one. We have two systems here. The first thing is whole circle bearing system. Okay, whole circle. Okay, in circle we will have how many degrees totally? It will start from 0 and it will end with the total 360. Okay, you can divide it into 4 quadrants: 0 to 90, 180, and 270, 360. Okay, so this is whole circle bearing. Now, if this is a north direction, you can give angle with respect to north from 0 to up to 360. Okay, whole circle you are using now. That's why this system is called whole circle bearing system. Then coming to the second one, quadrantal bearing system. Okay, same thing. We have north direction like this. Okay, instead of taking complete circle, we are going to now consider the quadrants. We know that this is first quadrant, this is second quadrant, this is third quadrant, next this is fourth quadrant. Okay, by dividing like this 4 quadrants, we are going to represent the angle of a particular survey line, right? That system is called quadrantal bearing system, right? We will see the first thing, whole circle bearing system. Okay, here whole circle bearing system. In this system, the bearing of a line is always measured clockwise direction. Okay, so this is the north direction, right? So with respect to the north direction, right, if I am taking B, so here I am taking a point B, line B, not point, it is a line. So I am taking an angle from north direction, this theta 1. If I am taking another line C, from here I am going to mark it as a theta 2. Another line is D, which is marked from here with an angle of theta 3, and finally we are having theta 4. Okay, like this, with respect to fixed north direction, every angle is represented. That's why now here we are going to take from 0 to 360. 0 to 360 is the total thing. Okay, now what is telling here? The bearing of a line is always measured clockwise direction from the direction of the north. From north we are going to measure the angles, okay, in clockwise direction, okay, and towards the meridian. Okay, so around a circle, like we are moving in a circle manner. Okay, the value of bearing of this varies from 0 to 360. From 0 we will end with again 360. The whole circle bearing will have been shown in the figure. This is the represented here. Here, for this kind of system, the compass which are using, that is called prismatic compass. This is actually given in your syllabus. Okay, the compass which is works on based on this system is called prismatic compass. Okay, next, quadrantal bearing system. Already I told that we are going to divide into 4 quadrants: first quadrant, second quadrant, third quadrant, then fourth quadrant. Okay, so now for first quadrant now, north, east, south, then west. North, east, south, west. Now the bearing or angle of a given line will be represented with respect to, in the previous system we represented with respect to north only. Now in this system you are going to represent the angle with respect to north or with respect to south. Okay, so when we will represent with respect to north means, if we have to take like this upper part and lower part. If the angle is located for first quadrant or fourth quadrant, either this side or either this side, right, that angle will be represented with respect to north. If any angle is behind this line, okay, this line, that means either back or front side of south direction, south side, we will represent the angle with respect to south. With respect to south. If angular line is above on this line, that is below, before or what is called front side or back side, that angle is measured or represented with respect to north. Now, if it is below this line, the angular line is located below this line, that will be represented with respect to south. Here, the angles will be from 0 to 90 degrees only. 0 degrees to 90 degrees. Okay, either it may be have to say in the direction. Okay, we will represent the angle like this. If there is any line like this, okay, the angle will be represented with respect to north. With respect to north, which direction it is located? Towards east. So from north we may take 30 degrees towards east. Now another line is located like this. Okay, another line is located with the angle of some, what I can say, 40 degrees. Now angle, how we are going to represent? North 40 degrees towards which thing? West, northwest. Okay, now coming to the another thing with respect to south. Okay, this is one, this is one. So from here it is 50. Okay, that's why that angle will be represented south 50 degrees towards east. Towards east. Now I am having another line with the angle of 45. Okay, in this third quadrant. Now I am going to represent south 45 degrees west. Okay, in what direction? West. Like this we are going to represent each and every angle in the case of quadrantal bearing system. Okay, the first thing is we have to remember here the angle value will be 0 to 90 only, right? If the line or angle which are going to represent in the first quadrant or fourth quadrant or angles near to north direction will be represented in terms of north, and which side, either east side or west side, that will be represented there. If the angle is below this line or it is in second quadrant or third quadrant or near to the south direction, we will represent the angle with respect to south, either southeast or southwest, like this. Okay, this is called quadrantal bearing system. In the previous system we don't have notation like this directly. With respect to north only we are going to represent the angle, that's why only single angle will be represented. This is the difference between quadrantal bearing system as well as the whole circle bearing system. Okay, now you can see in this figure with respect to the north, here alpha is the angle, so north is very good, alpha towards the east. Now we can see here this beta angle is represented above the south. Okay, south, beta, east. Now again in this third quadrant now, south, theta towards west. Okay, now phi is given here, north, phi towards west. So this is the representation of quadrantal bearing system. Okay, now conversion of whole circle bearings into quadrantal bearings. How we will convert? Okay, So the whole circle bearings of a line can be converted to quadrantal bearings by reducing it to angle of less than 90. Okay, which has the same numerical value of trigonometrical functions. Okay, so this theory you won't understand. You can see the table how you can represent, right? So now this is reduced bearing. Okay, reduced bearing na we will call this quadrantal bearing systems as a. It is also called as the reduced bearing system. Reduced bearing system. Why it is reduced? Instead of 360, we are using only 90 degrees now. That's why. Okay. Now you can see here a line AB. Okay. Now we will take like this. I am at A. I am standing at A. One line is like this. B. Another line is C. Another line is D. Another line is okay F. Okay, he took as a F. Okay. The first thing, line AB. Line AB, it is in northeast. This is the north. This is towards east. This is south. This is west. Okay. First thing is given as northeast. Northeast reduced bearing system, we have alpha. This is alpha. Okay. Now whole circle bearing for this first quadrant, whatever angle you took, that is the answer. Whatever angle you took, that is the answer. Since it is 0 to 90 only. Okay. Then coming to the second line, C. It is having an angle of beta. It is an angle of beta. Okay. South to east with beta angle. Okay. Now if you want to convert into whole circle bearing now from north you have to tell the value. From north you have to tell the value. From north to south, what is the total angle? 180 degrees. Okay. Out of 180 you have to minus this beta, then you will get value with respect to north. That's why in whole circle bearing system you are going to deduct reduced bearing, that is actually whatever value we are having here, we are going to deduct from the 180. Okay. Then coming to the third line, that is AD. Okay. AD is located with angle of theta. With angle of theta. So from north you have to move up to south by 180 degrees. Then you have to add remaining all theta value. That's why value will become 180 plus reduced bearing. 180 plus reduced bearing. If I have another line AF, it is located towards north phi west. From north it is angle of phi. Okay. Now if you want to get that value, you have to minus, you have to deduct this value from 360. That's why 360 minus RB. Okay. So you just note down this table and see the thing how it is working. Okay. Here in the whole circle bearing, for first thing 0 to 90, first quadrant. Second quadrant is here 0, 90, 180 and this is 270, 360. 0 to 90 first quadrant, this is 90 to 180, third one 180 to 270, 270 to 360. Okay, like this we will see. Okay, so now we will going to solve a problem so that we will understand the things very clearly. Now here convert the following whole circle bearing systems into quadrantal bearing. Now he gave, without giving representation of north, east and west, simply gave a angle. Okay, this is representation for whole circle bearing. Okay, now he is asking us to convert this whole circle bearings into quadrantal bearing system. That means with respect to north, south, at what it lays. Okay, the first thing is 22 degrees 30 minutes. Second one is 170 degrees 12 minutes. Right. Now third one is 211 degrees 54 minutes, 327 degrees 24 minutes. Okay. So now we will take we will draw the quadrants. Okay. This is north, this is east, this is south, this is west. Okay. Take the first angle. Okay. First angle, what is the angle? 22 degrees 30 minutes. Okay. So where it will come? This is the thing. 22 degrees 30 minutes. Okay. So from the table, according to our understood, this angle is located in between north to east direction. So the first answer for the first question is north 22 degrees, okay, 30 minutes towards east. Towards east. This is the answer for first thing. Then coming to the second one, that is 170. Here no, we have 180. Here it is 90. Here it is 270. Okay, we know that. So now second angle is second thing is located with the angle of how much? 170 degrees 20 minutes. But according to quadrantal system, it is near to the south. That's why we have to represent this angle with respect to south. Okay. From here we have to take. From here we have to say that is in towards the east. Okay. Now we can note down it is near to south and it is towards east. It is towards east. Now to tell the value with respect to south. Okay. So what is the total angle? Up to here it is 180. You have to minus, okay, that given angle from 180, that is 180 minus 170 degrees 20 minutes. Okay. Now it will give us 9 degrees 48 minutes. Okay. Then coming to the third value. Okay. Third value. What is it? 211 degrees 54 minutes. 211 degrees 54 minutes. Where it will come? It will be less than 270 and greater than 180. So in this third quadrant it will come. So from here, if you are representing the angle, it will be 211 degrees. Okay, 54. Okay, 54 minutes. 54 minutes. So it is near to south and towards west. This is fixed. Like this we have to represent. Okay. So then if it is in 211, that is more than 180. Up to here it is 180. From south is how much? Okay. To get that value, we have to deduct 211 degrees 54 minutes minus 180. We have to take out 180. Then only we will get the distance of the angle of this thing. Okay. So now we will get, by doing that, we will get the 31 degrees 54 minutes. We will get the 31 degrees 54 minutes from south to west. Then coming to the last one, 327 degrees 24 minutes, right? 327, it is greater than 270, less than 360. So the line will come here, right? So this is the angle from there. The angle from here to here, it is how much? 327 degrees 24 minutes. Okay. So now how to convert this? It is in near to which direction? It is near to the north direction. So north. And which side it is having? From north it is west. Okay. Northwest. You can write like this. Okay. So then it is more than 270 and less than 360. So for this fourth quadrant, what we have to do? We have to tell the angle from with respect to north. Okay. So from total angle we have to deduct this value. That means from 360 degrees you have to minus 327. Okay. 327 degrees 24 minutes. By doing that, by using your calculator, okay, so we'll get final answer of north 32 degrees, right, 36 minute, okay, towards west. Okay, this is the answers for this question. Okay, we'll solve another problem, okay, in this class today, which will ask us convert the quadrantal bearing to the whole circle bearing. Quadrantal to whole circle. So quadrantal bearing system, already we know that we have to represent in terms of directions. Okay, this is the thing. Now before doing this, we can again draw the all quadrants. Okay, north, this is east, that is 90 degrees, south 180 degrees, and west, okay, 270. Okay, so this is the thing we have to do. Okay. The first thing is north 12 degrees 24 minutes east. 12 degrees. Where it will come? Northeast. From here, northeast. From north, it is 12 degrees 24 minutes. So as usual, even whole circle bearing also, Here is the same value. So what is the answer for first thing? Very good. 12 degrees 24 minutes. The right answer. Then coming to the second answer, what he gave? Southeast. Okay, southeast. So from south it is 30. From south it is 31 degrees 36 minutes. 36 minutes towards east. How we have to get value? From here we have to get what is the angle. Okay, so we know that from here to here it is 180. Okay, so we can deduct this 31 degrees 36 minutes. Okay, so we'll get an angle of 148 degrees. Okay, 24 minutes. 148 degrees 24 minutes. Then coming to the third value, south 68 degrees 6 minutes towards west. So in this quadrant, this line will be located with the angle of how much? 68 degrees 6 minutes towards west. Towards west. So to get value from here, what you have to do now? You have to do 180 plus 68 degrees 6 minutes. Okay, so we will get an angle of 248 degrees, right? 6 minutes by doing this. Okay, next coming to the last value, that is north 5 degrees 42 minutes towards west. That means here with respect to north he gave in quadrantal system 5 degrees 42 minutes. To get this value, you have to deduct from 360, the difference value. Okay, finally you will get an answer. Okay, 360 degrees minus, what is the value? 5 degrees 42 minutes. Okay, so finally you will get a value of 354 degrees 18 minute. Okay, 354 degrees 18 minute. Okay, this is the procedure to convert the values from quadrantal to whole circle, and in the previous problem we saw whole circle to quadrantal, right? So you can take some other any example problems or previous JNDK problems, you can convert very easily. This is very simple, there is no confusion in this. Okay, right? So in the next class we will see how we are going to what is the forebearing, what is back bearing, how we are going in a survey we will have a traverse. Okay, what are the different traverses, then how we are going to calculate these bearings, from bearings how we need to calculate the angles, how we are going to calculate include angles, like that we are going to see. Okay, so thank you for today. Thank you.